Alright, so the last time we worked with you, we did step one of method of joints, where we determined the angles. I'm now going to move on. So I've taken another sheet of paper here and I've redrawn my truss and I've made some replacements. You'll notice I've replaced R of AY with force AY, which we already determined was 194.44 pounds. Still got the force of D, and of course the reactionary force of CY has been replaced by CY of 155.56 pounds. And I also replaced my angles with what I have determined already. So now we're going to start with the method of joints. And to do this, we're going to assume a couple of things. And we're going to basically break these joints apart. I.e., we're going to basically come in here on each member and we're going to cut these in half so that we will have a problem with joint A. And joint A, we're going to create free body diagrams on each of these. So here we have A, and we've got this force acting on A. We've got the force AD acting on A, and of course we've got this force here, AY, of 194.44 pounds. So there is our free body diagram. Now, you'll notice that I am drawing the arrows away from this joint because we are assuming that that is in tension. So, and you know, as we pull things apart, they're going to be in tension. If we compress them together, going the other way. So we assume everything is in tension here. Now we're going to find out if we get a negative sign when we start to solve these, then that's going to let us know that our original assumption of these being in tension was incorrect, and that it's actually in compression instead. So we're going to draw the free body diagram of joint A. We're going to draw the free body diagram at joint B. And at joint B, I've got a vector coming here, we've got one here, and we've got one here. No forces really applied on there that we know of, so not much help going on in there. Let's go on to joint C. And we'll draw the joint C. So we've got joint C here. We've got this vector going this way. We've got this one going this way. And of course we've got CY here, which is 155.56 pounds. And the fourth joint is joint D. So, and joint D has actually got one going this way, one going this way, one going this way, and our force at D, which is the 350 pounds. Now, again, as we do this, you are now faced with a choice. You've got your free body diagrams, you've broken apart each of these joints in the truss, and you got to decide, where am I going to start with first? Well, the first thing to start with is probably going to be the simplest joint, or the one where you have the least amount of forces to calculate. So in our case here, that's going to be either joint A or joint C. Now, since I know that I've got a 45 degree here, I'm going to go ahead and start with joint A as my first one, and begin to solve for each of these members so that I can determine what my forces are here and here, and then I will come back and be able to start to use these as I go systematically about from one joint to the other, solving each of these and replacing the magnitude on each of these vectors with what I've calculated out as I solve these. So that's going to be the next step as we go. This step is step 2. Step 1 was to go ahead and make sure that we had our degrees calculated out on it. Step 2 is to break apart the truss into the individual joints and redraw each joint as a free body diagram. So stay tuned for the next video as we continue our step-by-step method of joints to solve this truss problem. Thank you for watching.